Hi everyone, and thank you for joining our call. It's on a bit short notice, but I'm very glad to have you here. Without further ado, Maxim, I think you can just go ahead and start.
So I would like to do the third part of the demo of the new release, which is probably the largest release since the first release of RGB, introducing a lot of functionality. We already spent 3 weeks, three previous calls, sorry, not 3 weeks, but three previous calls to cover the parts of this release. Specifically, we already did a call devoted to the consensus level changes in the RGB core library, which was released on the 9th of February. After that, we moved to the standard library on the last call, where it was 9th of March, where I presented a lot of information about how new smart contract system works and how you can issue contracts, create interfaces, implement interfaces to smart contracts, and so on and so forth. There was also an extensive demo. And today, on this third call on this topic, we are moving to presenting a wallet library, which I signed off to the beta 1 release today. And you can see that release in GitHub. If you will go, you see my browser right now, correct?
Yes.
Yes, if you go to GitHub RGB working group organization, you will see the RGB wallet repository. And here in releases, you will see the RGB standard library beta 1, which was prepared today. There was a lot of changes. That's why it required much more work. I was planning to do this release a week before, but it took more time. As you can see, there is quite a lot of things has changed. The main two things which happened since the last week is the functionality that allows you to create a transfer consignments. And this can be done right in the memory, such that it can be implemented using WASM without any access to the file system. And this required actually to take the parts of the code which was present in RGB node and fully refactor them to avoid use of any database and any storage, to abstract the storage away. So this is the first PR, which you can check at here. It's number 21, so everybody is invited to review it, even though it's merged. The software is still beta, so it's always good to have a double check. And the second PR, which covers creating and accepting transfers from other peers and working with partially signed Bitcoin transactions. It's also quite large. It brings a support for partially signed Bitcoin transactions and a new workflow I will be describing today, which was much simplified comparing to what we had before with the previous version. And also it brings invoicing support and new invoicing support. So these topics which I would like to cover today during the call, it's how you can create a transfer, what is the overall workflow of the transferring RGB assets, and not just assets, just working with RGB contracts, calling RGB contracts, and doing more complex stuff with the multiple peers than just the transfers. The next thing is the invoicing protocol and different topics related to the invoicing protocol. Finally, there would be another part, which we will probably have on the 13th of March. And this is the part which I haven't time to finish until today. And this is a command line tool, which allows actually to use all RGB functionality from the command line. It is mostly complete. Last call, I was showing parts of it. The next day after it, I did a release, and right now the command line tool can create the contracts and do a lot of stuff with the interfaces and access the state of the contracts. But the parts related to the wallet functionality coming from the wallet library and PSBT is not completely yet. But I'd like to emphasize that the actual functionality is there. It's just that the interface for the command line is not ready. So it would take a few more days to finish it. So let's go with the style that we have for today. So three main things: working with the partially signed Bitcoin transactions, and which is the main point of integration between RGB and Bitcoin itself, Bitcoin transaction, doing the transfers and doing invoices. And I would like to start with the invoices. You remember before we had a dedicated invoice format which was looking pretty much like Lightning invoices and also supporting, it was developed not just for RGB, but supporting standard usual Bitcoin payments, mini scripts, partially signed Bitcoin transactions, and Lightning. However, with this release, it was decided to move from that invoice format. And the reason for that, there is a multiple rationales. I don't want to spend a lot of time on that. Those who are interested can go to the discussions in the LNPBP Association. Just use LNPBP Association and discussions, and you will see updates to invoicing. And feel free to read it and post your suggestions. But the reality is that with this version, with this release, we already have the implementation of this thing that we had outlined in this discussion. So feel free to propose. Maybe you will see how it can be improved further. So how this new invoicing is looking like? Well, it looks like an URL, and in fact, it is a URL. And it works as a URL. And the first part of the URL is, of course, a thing we call URL scheme. And it is RGB, which allows you to clearly see what's it all about. And all invoices are URLs making the life much easier, such that you can do a click if you send it over a chat or in an email even, you can always click with the mouse and it will open the software which you will configure as a default software for RGB. So it could be some of RGB wallets, and this invoice will be delivered directly to it. There is a number of URL schemes which are supported with invoices. The default one is just an RGB. And this is a scheme which doesn't specify a particular transport, how the transfer consignment can be sent between payer and beneficiary. There are more schemes which provide information about the transport, like RGB RPC, followed by a server name to talk to the RPC server, and it can be used for the existing JSON RGB RPC protocol developed by our community member. There is also initial work. It's not the part of this release, but it will be happening after, on supporting the HTTP REST protocol and WebSockets protocol, such that, for instance, WebSocket protocol can be used from browser extensions, and HTTP REST protocol may be more simple for several types of applications to integrate than JSON RPC. It's more modern. And finally, the consignments can be sent using the Storm network, which is a data layer on top of Lightning Network. And it was the protocol which was used in the previous demonstrations last year with the previous versions of RGB. And it will be also operational, and it will be signified with RGB plus Storm schema, followed by the address of the node and node key in the usual format. So it means that it's quite easy to take the RGB invoice, and you can do that by hand. You can prepend the specific protocol and the server you will be communicating through, and you will get another invoice, which will be also a valid RGB invoice. And the interesting part of the story is that there could be different wallets which support different URL schemes, and with this URL construction, it will be compatible such that if you are using one type of invoice, you're using one wallet and another wallet with other type of invoice. Or, of course, you can configure to have just a single wallet which supports all of these schemes. So the first part is the URL scheme. The part is the information about the contract. Well, for the fungible assets, for the tokens, it's just a token contract, but it could be any kind of RGB contract. And the RGB contract is presented everywhere through the RGB system as this string, which consists of base 58 encoding, this main part of the identifier, and a mnemonic representation of the checksum of this identifier. And this mnemonic representation is very important because it helps people to make sure that they're using a correct contract. It is human readable, and it is separated from the actual identifier via 0 number, which doesn't appear anywhere else. And it helps to, because people usually, when they get something like this, they pick several random characters in the beginning of the string mostly, or at the end of the string, or somewhere in the middle, and they try to compare, and it doesn't provide a secure means because it's really easy to mine an alternative contract which will share the same initial characters, and it can be used for phishing attacks. With this mnemonic, the mnemonic commits to the whole identifier. So even if you change a single bit of it, the mnemonic will be absolutely different and nothing like this mnemonic. And the space for mnemonic is 32 bits, which actually makes it hard to mine another identifier which would have exactly the same mnemonic. And this identifier would have a very different back 58 part of it, so it still can be distinguished. That is how the contracts are present in the system. The next thing is an interface name, which here is rgb.20. I was explaining what interfaces are on the previous call. Interfaces help to talk to different forms of smart contracts such that you don't need to update your wallet software to support a new form of contract interface. And finally, there is the last part of the invoices, so-called assignment. Assignment is the assignment of certain state to a UTXO in Bitcoin blockchain. The state is explicit here, so you're specifying how much of the assets you're transferring, and the UTXO, but the UTXO is hidden, such that if, for instance, I'm paying to somebody, that party doesn't need to expose information to me which specific UTXO in Bitcoin blockchain it owns. So here I have UTXO information mixed in with a certain random blending factor provided by the person who created invoice. And this blending factor is known only to that person, and it helps to hide the information which UTXO on the Bitcoin blockchain is actually payment going to. So this is the overview of this invoice string. And what are main properties of these invoices?
Yeah, go on. Can I ask a question? What about the consignment endpoints? How do I specify where I want to receive the consignment in the invoice?
Yeah, here these are. So when you are using different
how do you set multiple consignment endpoints as before? Like, for example, for resilience, one endpoint could maybe not available, so
right here. It's a standard way in the URL.
Okay.
You can connect multiple.
But this way, they will be in the same protocol. If I have one storm and optionally on proxy,
you can provide 2 URLs.
Double invoice.
Yes, double invoice.
But does the wallet? So wallet should parse a big QR code with double invoice with some information duplicated, like amount and stuff like that.
Well, like the reality that I think different wallets will support different protocols, and while several wallets would be supporting 2 or more protocols, I don't see how you can easily structure a single invoice which will operate with the different endpoints over different protocols. Because even the way how you specify endpoint is quite different depending on the protocol used. So another way how it can be solved is that you provide just unspecified transport and you provide endpoint information separately. So you just do invoice like this, and then you specify as a separate string the transport and endpoint additionally to this invoice. So this is another option.
I think that's a good idea. Could you go back to the invoice format?
Yeah, just 1 second. Another thing which can be also used and which also is standard to URL is that, for instance, if we support multiple protocols, we can have like this. And if you have the same endpoint operating on 2 different protocols, this also can be a way how you can specify multiple protocols. Of course, it wouldn't work for something like this because we have a different format for the server specification.
Yeah, I think like that, it could be quite a common use case that by default I use a Storm endpoint, but in case I'm not online, I have as a backup like a remote server, maybe like hosted by a third party. So yeah, I would consider it an edge case.
Mm-hmm. Like URL, I spent some time analyzing the actual URL specification, URI specification. It's very flexible. So in a standard way, you can do quite a lot of stuff. For instance, you can even do combinations like you can have an RGB followed by a number of protocols with their specific node points. Like for the case that Federica just told, you can construct something of this form. And then have the normal URLs followed. So this also will be standard because you can have components separated by the dots. So that's another option. So it's not part of the library, which the wallet library right now. So it doesn't support these complex schemes. But I think in the next versions, it can be developed to have that form of support. Sorry, Hunter, you were saying something.
Yeah, so could you go back to the invoice format?
This one.
The transferred state amount, so the transferred state.
Yeah, I will cover it separately. So there will be another slide about this thing, okay, because it's not only amount, it can be different things.
I was about to ask, because
yeah,
like RGB.21.
Yeah, for NFT, it will also work.
Yeah, okay.
Yeah. Anything else regarding this?
Well, yeah, also like in the past we had a discussion regarding the network identifier. Is it like with this schema possible to maybe add some optional fields that could be like network identifier or other stuff potentially? Also stuff like description, like this.
So this scheme is extendable, and the idea that you can prepend it with a so-called query and provide query parameters, like for instance, network name net. And they can be also optional, so they work like a TLV, and you can provide some non-standard parameters which will be recognized by some of the wallets and not recognized by others. For instance, something equals A, and so on. So I think that regarding the networking, it would be the proper way to put it as a part of this query string. I don't have a written specification for the query parameters, and we can work on it, like feel free to propose. And with this release, probably we should start thinking about what other things we need to have here.
Okay, yeah, I was thinking stuff like also descriptions or like identification.
Oh yeah, for sure. There are things like which I already had in mind, like signature over the invoice, like description of the payment or purpose, field or comment, and so on. Another thing that can go here is that this mnemonic covers just a contract. It doesn't cover the amount, the interface, and the UTXO. So for instance, somebody can replace this UTXO on the route. So the safe way, which again is not yet implemented in the current version, it will take more time, but what you can do, I will change the color to signify this portion, or what you can actually do is a thing like this. You can put a signature over the invoice, like it would be looking like another string. And with a hash, you can, after the hash, which is also a standard part of the invoice, you specify the mnemonic, which is commitment to the full invoice over which the signature is created. So for instance, it can be random body and matching the signature such that if any part of the invoice would be changed by any other participant, it can be detected because the signature wouldn't cover this anymore. So this invoice is fully protected from any man-in-the-middle types of attacks.
Got it, yeah. Looks nice.
And again, you just check the string and you're saying me, Federico, which invoice I need to pay? That random body morning invoice. Oh yeah, okay, I'm paying it. So it's an easy way to identify invoice. This is actually a unique identifier of the invoice. And in user interface in the wallets, it would be easier to show, for instance, like the name of invoices with this string. So I think it's quite frequently used in the Docker and in cloud environments that people starting using these mnemonics. And I picked that idea from there because it's much easier than just meaningless characters.
And yeah, one last question regarding the invoices, but then I guess when you encode it in a QR code, it will be a bit less efficient than a standard.
No, the interesting part is I have a dedicated slide for that. Why not base32? And I did checks. Base32 occupy exactly the same amount of space as base58. And yes, and that is very impressive. And the claim that is put in the base32 BAP is that it's more efficient in terms of QRs, but I checked with the different forms of base32, like different length, and none of them were more efficient than base58. So that was one of the reasons I switched back to base58, because you don't get any benefits from base32, but you still have a much longer strings. And with these invoices, because you need to provide a lot of information, the base32 basically doesn't work as expected, because it can't be longer than 80 characters. And if it's longer, its save guarantees, its error correction guarantees are not working anymore. So Lightning Net invoices in this case is a technical nonsense since they're much longer than 90 characters. And it uses base32 uses error correction code, which is put as last 6 characters, which nobody knows and checks actually. And this error correction code, it's really odd thing, because it is used to correct if some characters was misreplaced like this, and they can be automatically corrected. But if invoice contains characters which are invalid and replaces, the software shouldn't pay for it. So there is no reason to do error correction. If the checksum doesn't match, the invoice is invalid. So all these advantages of Bec32 are actually virtual, and the only real difference with the Bec32 is that it is not human readable, it's not compatible with URL, so you can't click just on the string and get your wallet opened, and it's much longer. So that was the reason for this switch.
Okay, nice, sounds good.
When checking the QR code you mentioned, have you considered putting the Bec32 string in uppercase? Because that's the big advantage.
Yes, that's exactly how I was checking with the uppercase.
And still it's bigger or the same?
Well, the same. For the shortest, it is the same. With the increase of the size, it goes bigger. Or the otherwise, I don't remember exactly.
Mm-hmm. Okay, thank you. Just curious.
I was actually surprised by that fact myself.
Yeah.
Now, let's see how URL scheme with this invoicing can work for more than just invoicing and more type of contracts. So the first thing that this is the invoice we was talking about. So it says RGB, contract name, interface RGB20, amount, and where to pay. If we remove the last part of the invoice, it will be still a valid URL and it will work with the RGB software. So what this thing says is it's not invoice anymore, but it will open a contract, this contract, displaying the available balance using RGB20 interface. So basically, if you click this string, you will see your balance on your wallet. And this is still a valid command. And even if you shorter it more, you will get the information about RGB contract. And when you do list your RGB contracts with the command line tool, for instance, this is the way the contracts are named. And this is the way how you can check the contract state independently from any specific interface and information about the contract. So these all are the same, these all are URLs, and invoice is just one of the forms of URLs which are used in the RGB ecosystem, and they can be easily converted into each other. Next thing, how we can cover more than just the fungible assets. Well, the thing is that this value part of the invoice is not specifically a number. It is so-called type at state. Type at own state. And the type of this own state defined by this thing, this interface, it specifies what is this. And the parser uses the interface information to parse this thing. So this could be, for instance, a hash of NFT you are transferring. And this would be a valid invoice under RGB21 format. Or you can do actually a call to contract. So the call to contract is also an invoice and also an URL. Here, you call contract to do an issue of more additional assets through the RGB20 interface. So this interface part can be extended with the name of the operation you perform on the contract, and additionally, with the name of the state that you modify. So here, for instance, if you have a contract that provides some, let's say, self-sovereign identifiers, you can put it like this. And it will work. So it will activate revocation procedure of certain identifiers. So this universe is really universal. This invoice and URL format is really universal way how you interact with RGB contracts and how you can send these commands to wallet and to RGB contracts without using anything like ABI in the Ethereum world and more complicated stuff. So that's it about invoicing. Hunter, did I ask your question regarding the NFT compatibility?
Yes, that was really cool. I can see how you might transfer more sophisticated forms of state if they're encoded in base 58 in any other named contract. One thing I also am curious about is how you get the name of the contract, like the blue part.
It's not the contract name, it's an interface name.
Right.
And the interface is, if I open the previous presentation from last week, not last week, last time we had it. So this thing where it is, find where I was describing this names of the interfaces. So each interface has a short name, and that short name is actually identifier of this interface. And while you can create interface independently from the association or anybody, these short names are standardized by association. So for instance, if you write your own custom interface, not the schema, and not interface implementation for the schema, but interface itself, in that case, you either need to put it into the registry, so it would have this short form, or you will use another string, like it would be something like this, but in blue. In that case, it means that it's unregistered interface, like this.
Could you do similar registration for like a contract genesis, like an ID?
Yeah, I was thinking about that. The point that interface is a really rarely created thing. So if you develop a custom contract, what you do is that you create a schema and you implement different standard interfaces for that schema. So I don't see a lot of situations where people will be doing new interfaces. While Genesis is just most common thing, and if we will have a registry, it provides a way how theoretically a set of allowed securities, for instance, can be censored. So we will instantly get pressure on the register to register or not to register certain short strings or tickers for the contracts. So nobody prevents from creating third-party registers, but I think it's better not to do that at the level of the RGB developers. Otherwise, it would be just a quite politically.
Yeah,
complex.
that makes sense. That makes sense. It'd be a form of centralization. One other question.
Where I will be showing you later that the tickers can be used in the command line, but it will be always extended to the full form in the invoice. One another option which I was thinking about is like adding this prefix to this string. That could be an option.
It would be like a human readable part, similar, like kind of like a...
Yes.
Yeah, kind of like a visual thing, but not necessarily like...
But not registered. So like there could be two different USDTs with using different words. So if people need to make sure that they are paying the USDT, the one that you would like to pay, and not some rogy one or scammy one, they just need to read USDT, which is direct detect equal and not any other string. So it's kind of thing that potentially could work.
One other question is, could RGB interfaces, and this is something that Gideon just asked, and I'll ask it verbally, is could RGB interfaces be sort of composed into sort of maybe like an overlapping or extended version of multiple interfaces into the same sort of invoice handler?
Like invoice, no. The thing is that invoice is a command, And the command is an operation performed over the contract. And operation is always performed through a specific interface, which specifies the parameters of this operation. So basically, if you need to perform two operations under two different interfaces, these are two different operations with two different invoices or URLs, which you can put in a sequence, like a sequence of operations and sequence of invoices.
Sure. So, like, what if I wanted to compose multiple contracts into, say, a new interface that it kind of calls other contract methods?
Well, it's a bit different in RGB. So here, the contract can implement multiple interfaces by itself. Each contract can have multiple implementations for multiple interfaces. A contract can have. So for instance, in our example, early example with the interfaces, I don't remember where it's, but we had in the discussion that there was a show how a contract does a token, identity, and something else. And it implements three interfaces for exposing this functionality. So this is the one option. The other option that contracts can depend on each other. So the validation of a contract state may include validation of some other contract state. And you can do that through the virtual machine, RGB virtual machine. It's not a part of the present version. And this functionality will be delivered later when we will do more critical estimation of possible impact in terms of which vulnerabilities it can introduce. And it will be done as a fast forward. You remember that we were discussing that RGB can be upgraded with these fast forwards, which are backwards compatible. And we made sure that this would be a backwards compatible upgrade. But for that, you don't need actually invoicing. You need to write a schema that does that validation and issue a contract under that schema. And still, probably you would need to create another interface that covers that, but it would be just some other interface, either standard or non-standard. But in that way, you can create an invoice that does this validation of contracts, multi-contract operation or something of that sort.
I think that answers the question. Thank you.
Yeah, you're welcome.
So example was actually in contractum language repository for multiple interfaces.
So can you repeat once again, please?
Those example for multiple is in contractum repo.
Yes.
It's very good actually.
It's somewhere, yeah, here, like schema, which implements one interface and another interface. Like one interface and second interface, yes. And two different interfaces, yes, that's the example. Thank you. So that's all for the interfaces part. Next, I would like to move to how the actual workflow of state transfer works. So the workflow is pretty simple, and still it is more advanced than we had with the previous version, because now it includes quite important suggestion from Federico that the beneficiary has to sign that he accepts the transfer before the sender can publish the transaction. It's not a required stage, but it's very helpful such that the state is not lost. So it's an optional thing that can happen. So the workflow is the following. Actually, there are two workflows, simplified and more long with this signature. Let's say we have Alice payer and Bob, who is beneficiary. Bob creates an invoice and sends to Alice by some means, like email, shows QR code, through the website, any possible mean, through the chats, any possible mean would work. Alice scans the QR code with a photo camera or clicks the link. It opens a wallet which actually creates the PSBT and consignment. The PSBT is being created, stored, but not yet signed. The consignment is the final consignment, and this consignment is sent back to the Bob. How it is sent? Well, it is sent according to the invoice schema, so via these endpoints. Or if the schema is not provided, it is sent by some other means, like it export to the file and you send the file through the email or any other way. By the way, you can include the consignment into an email because any consignment has this base 64 armored format such that you can put it as a text into the messenger or into email. Bob receives that consignment, it does the verification of the consignment and instantly merge it into the stash. Because even if the final transaction is not mined, the moment that it will be mined, it will become a valid state. So there is no reason for the Bob to postpone the merge of the consignment to the stash because until the transaction is not mined, it is not displayed as a proper state. When it's mined, it gets displayed. So stash can contain state which is not yet mined. At the same time, Bob also creates a signature over the consignment ID and sends it back using the same transport protocol, if the transport protocol supports that, like RGB, RPC, sends it back to the Alice. And when Alice sees that the Bob has accepted the payment, it finally signs and publishes the PSBT and Bitcoin transaction, and it gets mined. So in this, like we have 3 rounds of communication between Alice and Bob, and this setup is a secure setup. Another way how it can happen is with just 2 rounds, when Bob's at the same time does the consignment and publishes the transaction. It's more risky, it's less interactive, but it's more risky because the risk is that Bob, for instance, claims that he never received a consignment, and then Alice has no means of proving that. So these are 2 setups which work with RGB. Federico, does it matches your comments which you was suggesting before?
Yeah, it seems in line with also what we are already doing in Iris Wallet.
Yeah, and that's how this protocol works. Not with the Storm yet. Okay, now how it works, yeah.
Could I ask one question? So let's say, so like when you transfer an asset to someone, you're sending it to a blinded UTXO, and let's say they were to transfer some assets on their end, which would be kind of spending that UTXO. Could that be like a major issue in terms of like if 2 things happen at the same time? There would be no contract or state transition that would be valid for both token transfers. They happen
I'm
both.
I'm not sure how they can happen at the same time, actually.
Well, like even let's say they were even within the same block. Like Alice were to do a token transfer after providing a blinded UTXO to Bob. And say, Bob sends to that blinded UTXO, which has now been, sort of put into the mempool, right?
Again, the UTXO is not the UTXO of the transaction you are doing the payment with. That's the whole point, because with RGB, you can pay to already existing UTXO, a long time existing UTXO, which doesn't need to be mined. It can be a UTXO of the transaction you put the commitment into, so-called witness transaction, but it can be a different UTXO as well. And the secret is kept by Bob. I showed it here. So it has to store it in the wallet. Actually, today, RGB does that automatically. RGB standard library. You don't expose secret to the user anymore as before. And it kept internally. So when it receives the consignment, it matches it against invoice through this secret thing. So the secrets thing is actually invoice identifier internally. And even if the transaction is not mined and UTXO belongs to that transaction, when UTXO, which you are paying to, belongs to the transaction which is created by the Alice, then you send a special type of seal, and it looks like this. Let me show you. Like this, because the transaction identifier doesn't exist yet. So in this case, it can be clearly seen that the data should be put directly into the, for instance, first output of the spending transaction. And in this case, you don't have that risk. If you're using existing UTXO, it's already existing, it's already mined. So again, there is no risk with this secret thing. Hunter?
Yeah, I'm just thinking that through, that you could sort of omit the blinded UTXO, and when you provide it to Alice, Alice doesn't even know that the blinded UTXO that Bob would send you, and so then they would prepare a consignment with sort of this sort of partial.
No, it can't work like that, because you commit to the blinded UTXO in the transaction which is here, because it's a part of the state and it's part of RGB state, and you can't.
So, so what is that new thing you just showed, like with the tilde?
It's not new. It was existing before. So let me go to the command line. When you create this thing, you just, as a part of the specification of where the payment goes, you put the tilde, which means it will be present in the witness transaction of the payment.
Okay, I'll have to think about that. Thank you.
Okay. So that's the workflow. Now let's see how it actually works. And I will be sure, because we don't have any user wallet interface yet that supports version 0.10 and this new workflow, I will show how it works from the command line. But the reality is that it will work the same for any wallet which will be integrating RGB. You just will replace this yellow word with an API call. And this would be parameters of the API call. So basically, that's how the command line is working, that it just calls the API of the RGB wallet and RGB standard library with these names. So the transfer starts with the creation of invoice, and the invoice is created by Alice by using this RGB command. I was saying last time that now we have just an RGB command line thing, one. Before we had a lot of them, of different command line tools, and also it was required to run a node. Right now, it's not required to run a node. RGB works like a Git, storing the data locally in the directory. You still can run a node and talk to that node, and in this case, it would be RGB CLI command, and it could be a remote node. But the most common case would be just simply you do the installation of local binary, which is called RGB. You don't need any database, you don't need any network connectivity, you just run command line thing. And you say RGB invoice, you specify the interface name, then you specify amount of tokens you would like to invoice to. And if in case of NFT, this would be looking like this, and here you will get the hash of the NFT instead of this number. Then you specify the contract name. Here I'm using the short form of the contract name. It can be just a full contract name coming from here. So any of that will work as you prefer. And finally, you provide information of the destination of the payment. Unlike invoice, where this is a blended UTXO like this, you provide an explicit information about the transaction. I put 2 dots because it doesn't fit on the screen, but basically this is Bitcoin transaction and output number. And you prefix it with a commitment scheme. By default, it would be a top-red commitment scheme, but we have 2 commitment schemes including op-red commitment scheme. And you can modify that by adding this optional prefix. So this creates an invoice, the invoice we just have seen. And this thing is actually enhanced with this secret factor, which stored in RGB command line tool, and then converted into this. So it's basically a hashed version of this plus a blending factor based 58 encoded. And this USDT is contract which is resolved into this thing. RGB goes here into the invoice and the amount goes here. So that's pretty simple. Each interface have a thing which is called a default operation. So basically you can create invoice for a different operation, like for operation of issuing of secondary issue of the asset, and then you provide the operation name. If operation name is not provided, it defaults to the default operation of that contract. And the default operation is defined by the interface itself. Then this invoice goes to Bob, and Bob does 2 things. First, it uses its wallet to construct a new PSBT. And here I would like to emphasize that RGB command line tool here is not a wallet. It doesn't work with a public key. It doesn't work with a knowledge of which UTXO is owned by the user. It can do certain wallet-like things, like if you run RGB state rgb.20 for the USDT contract, this command will show the state of the contract, and it will show you all the known state, including the state that you own and you don't own. But if you'd like to filter, you can add a filter command and provide a descriptor which will filter UTXO set. And this descriptor is actually your wallet. So this is the way how you can filter the state which you own. And the same way it works for the Bitcoin wallet integrating RGB, you just provide a descriptor to RGB standard library. But here, RGB can't construct the Bitcoin transaction because it doesn't know a lot of things. And you just need to use any wallet, which I will be showing it actually on the next call, how you can construct a PSBT with a spiral and use it together with RGB command line tool. So you construct the PSBT first, and this PSBT must span some of the state that you own in RGB. And in RGB wallets, it will be actually hidden behind the wallet interface itself. And then wallet calls, user interface of the RGB wallet calls, or user use the RGB command line tool to prepare the transfer. With the transfer command, it takes the PSBT, it takes the invoice, and it creates a consignment. So it saves this data to the consignment file, creates it. So what it does, it analyzes the inputs of the PSBT file. It checks which state, RGB state, exists on these inputs. It analyzes outputs of PSBT file. It saves the change to one of those outputs. Actually, there is a flag called change, which you can modify which output is to use for the remnants of the state which you don't transfer. It analyzes invoices, and it does all this analysis internally and constructs that valid consignment that does all of that stuff. Before, we had another thing which called disclosure. We still have disclosure today, but it's not now required to use it explicitly. So it produces this disclosure internally and stores this internally. It doesn't expose it to neither to the user or to the RGB wallet working with the RGB standard library. So Bob does do this thing. It just creates, with the one command, it creates a consignment, and then he sends this consignment back to Alice, as we discussed, with this transfer consignment protocol coming from the invoice. So for instance, this was RGB RPC, and then he sends with RGB RPC to the Alice. Alice now have consignment RGB file, and it does just a very simple command, RGB accept consignment RGB, and that's it. The result of this command is the signature. So if the consignment is valid, it is merged into the stash, and the command returns a signature which can be sent back to the Bob. If the consignment is invalid, of course, it doesn't merge, and it says that the consignment is invalid and the signature is not produced. Bob receives the signature. Now it can sign the PSBT file, again with the wallet, and use RGB to check the signature and publish this transaction file. It actually, you can do it differently. You can just do check first with the signature, make sure that the signature is valid, and then use Bitcoin wallet to sign and publish transaction. So that's another way of doing the same thing. And that's it. That's how the whole RGB state transfer works for both NFTs, RGB, fungible assets, secondary issuance, anything else. So it's a quite dramatic change from what we had before. If you probably remember, there was a script of doing RGB transfer. There's several screenshots about this workflow. Now it's all reduced to these several stages. So if I will look into this terrible script, you see how a lot of stuff had to be done in order to do the transfer before. Now it was possible to compress all these things, partially because of the interfaces which were introduced, and partially because of the knowledge which we acquired through the wallet integration over this last year. So
we just got a question from Lunas. It was asked, why does Alice need to sign the consignment?
Oh, it doesn't need to. So as I said, there are two types of workflow. In the first, Alice signs the consignment. In the second, she doesn't. The reason why she may need to sign the consignment is because Bob requires Alice to sign the consignment. And before Alice signs the consignment, he doesn't publish his transaction. And by doing that, Bob protects himself from the fact that Alice would later say that, no, I never seen your consignment. I never received it. So the signature is actually a kind of pay slip for the Bob.
So it's almost like a proof of payment, or?
Yes, it's a proof of payment. It's a proof of receival of the payment.
Nice. Okay. I think that answers this question. Yeah.
So it's pay slip, like Alice is a receiver. If Alice is a merchant, it is actually the signature is a pay slip the merchant gives to the customer.
I have a question again, sorry, regarding the invoice again, but it came later.
Yeah.
So what about the case where the receiver doesn't want to specify the asset ID? It just wants to specify the blended to tick, so where he wants to receive the asset, but is happy to receive any amount of anything, like a donation or I don't know, for new assets that are not popular and the receiver may not know the asset ID, this kind of stuff.
Well, I'm not, like we had this discussion before, I'm not entirely convinced that pay with any asset is a thing that can work, but you can do like this.
Okay.
Like this single, and it will mean that the asset is unspecified, but you specify the amount of asset, or you can even skip the amount of asset, like do quite weird stuff.
Yeah, I mean, for the nation, I would expect it will be easier not to specify the amount of assets, so people can just send whatever they want.
Yeah. Well, you just skip the amount in this way. Let me remove the, like this.
So you can skip the amount, and you can also skip the asset ID if you want.
Like this, yeah. So you have to specify the interface still, because it's actually a classification of the contract, and you need to provide where to pay. So these are two things, like a minimal how a minimal invoice could look like.
But why is this schema interface name mandatory? Because before that was why the schema is mandatory? Couldn't we just
the schema
provide
is
blinded?
mandatory because without it, it wouldn't be recognized by software. So it's like a
No, not that part. The interface name. Sorry, the RGB part.
The interface name is mandatory because it's not clear which operation to perform. Like
if it's a donation, whatever operation the sender wants to.
Well, the send operation is the specific operation, because there could be like issuing asset or transferring NFT or revoking your identity. So without that, I don't know, do I need to revoke my identity or issue a new asset or do whatever? Like doesn't sense anything to me.
I think there could be one thing it could do is it could just list what interfaces it supported.
Well, it's without specifying interface, there is no way how you will prepare a state transition. Just no way.
Right, but like in one of your previous examples, if you omitted the amount, it would show you your balance, right? And if you omitted...
No, not amount. Just give me 1 second, I will turn this back. Not amount. If you omit amount and the seal and the address, this will show you the balance.
Okay.
But not like this. This wouldn't show you balance. It will prompt you for a payment where you can change amount you are paying to or provide an amount, custom amount.
Okay, no, regarding the interface, I mean, like if it's not specified, it would be something like the sender knows what he needs to do. And to give you an example, let's say that the sender knows what he needs to do because the users went to, I don't know, the send button of a specific asset that has a known interface. So when I scan a QR code from there, I know that it's an RGB20 operation, not an RGB21.
Yes, but for instance, on the practical level, if, for instance, there is a QR code on the street, and this QR code looks like this, like I scan it, it opens my RGB wallet and says that pay whatever you want, send whatever you want to this address, and then you select a contract, an asset, and amount, and the operation you're doing on this amount. I don't know.
Well, yeah, I mean, of course, not every wallet would be able to do everything, but I expect like if you scan this string once you're already like in the send page of a specific asset, then the wallet knows what it needs to do. If it's not, it may not be able in the case, but yeah, I mean, not everything can work. So.
A great property of URLs is that they are opened for the modifications. And it still will be a standard way of modifications, like even constructing this weird URL. And maybe some wallets wouldn't support it, but you don't need to, like with the previous invoice protocol, you had to modify the code of the library and the actual standard and introduce new TLVs and so on. So here, you are free of that burden.
Okay, so yeah, basically everybody can do whatever he wants. Up to the wallet to be able to do something with the string. Yeah. Okay, fair enough.
So that's all for the transfer workflow, which I was going to show. Do we have any questions regarding this part.
Yeah, I have a question, Max. You mentioned you're going to show the Sparrow demo, and Descriptor wallet is also like up to date now, so it can be fully used.
No, the Descriptor wallet is actually not changed. So before we had this architecture. Let me show you.
Because I like it very much and I want to use it like on the server side.
Yeah, the Descriptor wallet now will be a separate thing from RGB, meaning that it will use RGB, but it is not required for RGB itself. So it will be updated later with a node and everything.
But can I use it instead of Sparrow, for example?
Well, theoretically, yes, you can. Yeah, nothing prevents you from using even previous version of the wallet.
Okay.
One more thing that I forgot to tell you about this release, which I did today, is that I updated all the libraries to the latest versions of the software. So I used the new version of SACP 258K1, which was released just yesterday. I also I published the update of the RGB core library and the rest of the library. So there is a next minor version increase for that. I don't use Rust Bitcoin anymore anywhere in the libraries, core library and standard library. But for working with PSBT, I'm still using Rust Bitcoin library. And this library also I updated to 0.30, version 0.30, which was released just yesterday. And this is quite important thing that it is now all the version 0.10, all libraries are on the latest version of all available software. And I think it would pass at least another half of year till the next Rust Bitcoin release. So there would be no need, if you start using RGB 0.10, you wouldn't need to do another upgrade soon to the Rust Bitcoin as well. That's the other thing. And one more thing, we are working. It's public. Anybody can go and see it, but it's not final. But to let you know, we are working on the blackpaper of RGB, which is a white paper. It's already quite large and it's half completed. So the whole client-side validation part is there. The RGB application layer is not finished yet. But you can look at it and even do a pull request if you would like to. And also we are doing a large update to the rgb.tech website, which is coming soon. It's in a beta. And it has more streamlined information flow that will help to people who are not technical and who are first time hearing about RGB to get to know what it is and what it does and how to start interacting and working with that. So that's also things which are coming quite soon to be released. That's all on my side.
Amazing. Thank you very much. So guys, do you have any more questions? So far we have covered quite a few of them.
Yeah, I think we covered most of them during the presentation.
Mm-hmm. Okay then. I think we can wrap this up. It's been 1.5 hours. Good start.
Thank you everybody for joining.
Yeah, thank you everyone for joining. Thank you, Maxim, for very informative slides and explanations and answers. And see you all next time. Bye-bye.